So following on from the previous video, we were trying to find values of x for which the whole power series will converge. And the way we did it was to use the ratio test. So when it comes to the ratio test, we always need to compute this value. It turns out that this value here equals the absolute value of x. So the ratio test says that if this value here, the ratio test says that if this value here is greater than 1, then we know this power series will diverge. If the absolute value of x is less than 1, we know that this power series is going to converge. And then the ratio test also says that if it equals precisely 1, then it's inconclusive. So if you look at this, absolute value of -1 equals 1. Well, this thing here it equals 1, so therefore it's inconclusive. So it's inconclusive here and it's inconclusive here. So now we need to investigate what happens when x equals precisely 1 and precisely -1. So now let's investigate what happens when x equals precisely 1. So if you put 1 into the x here, so that will be 1 to the power of n, which is just 1. So when x equals 1, you put it into here. This whole thing here will then become this. So now let's see what happens when n equals 1. When n equals 1, put it into here and put it into here. So the whole thing here will become 1. When n equals 2, put it into here, it will then become this. So it's going to become it will be 1, -1/2, +1/3, -1/4, and so on. This is an alternating harmonic series, and we've seen in the past that, well, the normal harmonic series will diverge. We've seen this, but an alternating harmonic series, hang on, -1 to power 1 over n, an alternating harmonic series will converge, and we've seen this many times in the past. The normal one will diverge, the alternating one will converge. We've seen this. This here we've seen in the past that it will converge. So in the case of x being equal to 1, this whole thing here will converge because it's an alternating harmonic series. So now we need to consider what happens when x equals -1. So when x equals -1, we need to put it into this x here. So that becomes this to the power of n, and then tidy this up. So you've got one block multiplying a fraction, so it gets multiplied to the top. So when these two are the same, so it's a matter of getting this, add this. So when you add these two together, it will then give you 2n and then -1. So n is moving from 1 to infinity. When you times it by 2, it will be an even number. Take away 1, it will be an odd number, and an odd number times this is always going to be negative. So this thing here, this whole thing here, you can consider it as always being negative. So consider that as being negative. So now this is a constant, so take it out. So that will then give you this. So when x equals 1, in the case of x equals 1, you're going to have this. So this is a constant. You can take it out. That will then take you to here. But then if you look at this is a normal harmonic series. So it's going to diverge. But because you've got a negative here, the overall thing here will negatively diverge, if that makes sense. Well, the point is that this is going to diverge. So going back to the original. Remember the ratio test, if it equals 1, if the absolute value of x equals 1, it's inconclusive. But in this scenario here, when it comes to this function here, when it comes to this scenario, when it's dead on 1, we've seen earlier that it's going to converge. Therefore, our domain here, so dead on 1 is in our domain, so you can select dead on 1. Okay, so you can actually put the number 1 into here because we know it's going to converge. Therefore, it should be able to spit out a number. So 1 is in the domain. But then -1, we've seen that it would diverge. we see -1 diverge. So -1 is not in the domain. So -1 is outside of our domain here. So the values of x, which will allow this series to converge, will be strictly greater than -1, will be strictly greater than -1, but it can include the number 1 itself. So our domain is actually this. This is our domain here. Our domain is actually from strictly greater than -1, but it can include the number 1 itself. Okay, so yeah. Okay, so when it comes to the ratio test, the absolute equals 1 is inconclusive. So you need to investigate. You need to investigate that on 1 and that on -1. Okay.